Welcome everybody, it's Ramachandra from Civil Mech Concepts channel. This is my second lecture for the benefit of the students who are appearing at various levels of Mathematics Olympiads in their countries, and it is regarding prime numbers. I have released a first lecture on ratio of a series, and which is also useful. That also you can see from my channel. Best of luck to everybody, and in this I want to ask 65537 whether it is a prime or not. We will be solving it in seconds so that you will excel with good scores in your Mathematics Olympiad conducted in your country. Best of luck. Thank you. Welcome everybody. It's Ramchandra from Civil Mech Maths Concepts channel. Today I'll be giving one good example in this lecture as a practice problem for Mathematics Olympiad. On prime number. The question is, it's a practice question. Question is 65537 a prime number? We are not allowed to use the calculators. Not allowed to use calculators. Then how to find whether this particular number is a prime number or not? Let's understand what is a prime number. Solution. Prime number is a number which has no factors except 1 and the number itself. For example, 3 is a prime number because it cannot be divided by any other number other than 3 itself and unity. 5 is a prime number. 7 is a prime number. But 9 is not a prime number. 9 is not a prime number. Because it is 3 into 3 is equal to 9. 3 is a factor for it. That means all odd numbers are not prime numbers. 11 is a prime number. 13 is a prime number. 15 is not a prime number. Then, how to find out which number is a prime number and which number is not a prime number? Especially in case of numbers like 6, 5, 5, 3, 7. Prime numbers are not following a particular pattern like arithmetical progression or geometrical progression, and at higher numbers, few quadratic equations are there. They are valid up to x is equal to 80 or prime number up to 1601, and the prime number given is 65537. Then how to find? There is one scientist called Fermat, mathematician or scientist we can say. He introduced the concept of prime number, and he said that 2 to the power of 2 to the power of n plus 1 is a prime number. But the later computers, calculations and supercomputers, they have told that it's confirmed that for n is greater than 5, n is greater than or equal to 5, the above rule breaks. Now let us see whether 65537 falls within this particular rule. Now 2 to the power of 2 to the power of n plus 1 is equal to this Fermat rule. Please remember, 2 to the power of 2 to the power of n plus 1 is equal to 2 to the power of 2 to the power of 1 plus 1, that is equal to 2 to the power of 2 plus 1, that is equal to 4 plus 1, that is equal to 5, if n is equal to 1. 2 to the power of 2 to the power of n plus 1 is equal to 2 to the power of 2 to the power of 2 plus 1. First 2 to the power of 2 is 4, 2 to the power of 4 plus 1, that is equal to 2 to the power of 4 is equal to multiplication of 2 4 times. 2 into 2 is equal to 4, 4 into 2 is equal to 8, 8 into 2 is 16. That is 16 plus 1, that is 17. It is for n is equal to. This is the third Fermat number. 2 to the power of 2 to the power of n plus 1 is equal to 2 to the power of 2 to the power of 3 plus 1. That is equal to 2 to the power of 2 cube. 2 cube is 8. 2 to the power of 8 plus 1. That is 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7, 8 plus 1. 2 into 2 is 4. Again 2 into 2 is 4. Again 2 into 2 is 4. Again 2 into 2 is 4 plus 1. 4 into 4 is 16. Again 4 into 4 is 16 plus 1. That is equal to 256 plus 1, 257. This is n is equal to 3. This is the third Fermat number. Now 2 to the power of 4 plus 1, that is 2 to the power of 2 into 2 into 2 into 2 plus 1. 2 to the power of 2 to the power of 4 is 4 into 4 16. 2 to the power of 16 plus 1. That is equal to 2 to the power of 2 to the power of 8 plus 1. That is equal to 2 to the power of 4 to the power of 4 plus 1. What is 2 to the power of 4? 2 into 2 into 2 into 2 to the power of 4 plus 1. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. 16 to the power of 4 plus 1. Then this becomes 2 to the power of 2 to the power of 4 plus 1 is equal to 16 to the power of 4 plus 1 is equal to 16 into 16 into 16 into 16 plus 1. What is 16 into 16? 256, which we have seen earlier. 16 into 16 is 256 plus 1. That is equal to 256 into 256 plus 1. What is 256 into 256? Let us do maths here. Multiplication. 256 into 256 is equal to 6 6 are 36. 6 5 are 30. That is 3. 6 12 are 12. 12 plus 3 15. 5 6 are 30. 5 5 are 25 plus 3 28. 5 10 are 12. 10 plus 2 12. Then 2 6 are 12. 2 5 are 10. 10 plus 1 11. 2 2 are 4. 4 plus 1 5. What is its value? 6 3 5 plus 8 13. 13 plus 2 15. 1 plus 1 2. 2 plus 2 4. 4 plus 1 5. Then 5 plus 1 6. This is equal to 6 5 5 3 6 plus 1. That is equal to 6 5 5 3 7. It is a prime number. As per Fermat rule. As per Fermat rule, 6 5 5 3 7 is a valid prime number. Beyond this, if you take 2 to the power of 2 to the power of 5, that is not a prime number as per Fermat rule, because any number n greater than or equal to 5 is not a prime number in Fermat rule. What is the Fermat rule? 2 to the power of 2 to the power of n plus 1 is equal to prime number for n is less than 5. It's a natural number. N is a natural number. Please remember this, and if possible, try to remember the 4 Fermat numbers. What are the 4 Fermat numbers which are primes? The 4 Fermat numbers are 5, 17, 257. 5 Fermat numbers are 5, 17, 257 and 6 5 5 3 7. I'll give further insights into the prime numbers in my future lectures. how to find out the prime number, and it is one of the rules, Fermat rule, and other rules also I will let you know. Best of luck to everybody in the International Mathematical Olympiad, and my lectures will be continuing like this. And in my lecture 1, it is lecture 2, in my lecture 1, I have given a hint about how to do the division of two series. A series can be expressed as a number or expressed as a function, and one function divided by another function is a series divided by another series. That I have already given. That question I will write it again here, and you can see my previous lecture for that. I have given various series, and from that series I have asked you to calculate a ratio of a particular series. The ratio of a particular series depends upon the series to which the number to which or a function to which this series is meant for. The question is if x is equal to 1 minus 1 by 2 plus 1 by 24 minus 4 divided by 1 minus 1 by 2 plus 1 by 3 minus, then find greatest integer x such that x is less than or equal to the greatest integer such that it is less than or equal to x. This is the greatest integer function. You find the greatest integer such that it is less than or equal to x. If x is equal to so and so. This is the question. I have given the solution. In my lecture, the question is put in the thumbnail. Similarly, the same question is put in the thumbnail, and you can see that. And the answer is zero. Answer is 0. I will give the hint here. The numerator is cos 1, denominator is ln 2. The x value is equal to cos 1 by ln 2 0.540 by 0.693, which is equal to 0.78, which implies greatest integer x, which is less than or equal to x, is greatest integer value which is less than or equal to x is equal to 0. That is the answer. From the greatest integer function. The value of the greatest integer which is less than or equal to 0.78 is 0. This is the answer. I feel these two questions may give you an insight about the way I explain the mathematics for International Mathematical Olympiad of various levels of examination, and I'll be releasing, whenever I get thoughts, I'll be continuously releasing the questions, typical questions to you, and you try to understand the concept behind them and try to solve the questions on your own. These two questions I have solved, and I'll come up with more and more questions in future. It's Ramchandra again from Civil Mech Maths Concepts channel. Best of luck to you. And I am an IIT alumni. I thought I'll give some insights in the mathematics, as I've taken mathematical modeling as one of the projects in my work. With that background, I thought I will give some insights in the mathematics for GATE engineering mathematics and also for the Olympiad examination, Maths Olympiad. Best of luck to everybody. Thank you. Thank you for listening to me.